Okay, we are going to make soap. The reason being, yesterday I was complaining in the staff room, the one thing this place doesn't have is soap. And I thought to myself, I was just busy complaining when Ms. Jacobson brought in hand sanitizer for all of us, so we're good. But then I thought hand sanitizer is not good enough. You've got to wash your hands with soap. You can't always put some hand sanitizer on. So we're going to try, or as Yoda says, there's no try, there's only do. So we're going to make soap today. We're not going to try and make soap. So to make soap, we're going to use sodium hydroxide pellets. So sodium hydroxide is otherwise known as caustic soda. This stuff is pretty ancient, but it looks okay. Try not to touch it with your hands. So I'm going to put 1 part sodium hydroxide there. Now I'm just trying to think what I can shake it in. Okay, so there's about 1 part sodium hydroxide. Then I need 2 parts water, about twice as much as that sodium hydroxide. I guess that's about right. And then I need oil. So I brought this oil. It's a mixture of chicken and old sunflower oil. I'm a bit of a cheapskate. I never have leftover sunflower oil because I always just use it up on chips and things. So there was a little bit of, I think, chicken fat. Never throw the stuff down the sink, guys. It just blocks your sink. And then you've got to throw drain cleaner down to turn it into soap in the pipes. So that's actually what we're going to do. So we're going to take I'm going to actually take about that amount of oil. So it's actually almost the same as the water. Now the thing is, you can use about up to 8 times the oil as the water, and it will saponify it. And what it means is the more oil you use, the less hydroxide in your soap, so it won't be so harsh on your hands. You don't want to put hydroxide on your face. But the more oil I use, the less oil I use, the less time it takes to harden. So I'm interested in both of those. But anyway, so do we add the sodium hydroxide to the water or the water to the sodium hydroxide?
Sodium to the water.
Okay, sodium hydroxide to the water. In fact, I'm going to just use a little less water because I haven't got that much oil. So we're going to add that and stir. You could use gloves. You will immediately feel that gets warm because it's an exothermic reaction. So I just want a few people to feel it, just to see, am I lying? Is it getting warm?
Yes, sir.
Okay, so
Yes.
Getting warm?
Yes.
So if you added the water to the sodium hydroxide, it can get so hot that it boils out. Try not to breathe the vapors either. Okay, so if you use the stuff, do you feel that it's a exothermic reaction? It's hot. This will remove anything, my friend. Swallow it and it'll remove you from this planet. Okay, so do you see that it dissolves reasonably easily? Did you feel? Okay, now the next thing to do is to add this to the oil. Makes no difference. It's nice that it heats up the oil as well. So we're just going to throw that in there. And then we shake it up. I normally like to do it in a plastic bottle because, you know, plastic, if it explodes, doesn't kill anybody. Do you see how it looks all saponified? Yeah. Do you see that you've actually got oil and water mixing a little bit? And this you have to shake for 5 minutes. Yeah, but I don't want to lose a student. I'd rather kill myself. But if you don't mind, thank you.
Yes, you know he's a professional. He's experienced.
So I was going to be now finish it. You get that all, but I'll get with you.
Thank you very much. That's great.
Bro, 5 minutes, bro. Oh, you didn't let me. Make it slowly.
Oh, you want me to go slowly?
Yeah, slowly.
Are you sure you're going to finish now?
We're hoping for a happy ending.
I have been.
Okay. So now we get a mold. In case it gets stuck in there, I've got a piece of silver foil. So I'm just going to mold into there so that it will come out. And the soap is going to form the shape of the mold. So there's our mold. Now, because I want to put this in the staff room and I don't want anybody stealing my soap, I tie a knot in it. I put the knot into the mold. When the soap forms, it's going to form around the knot, so you can't pull it out. And then we got soap on a rope, which I'm going to tie to the tap. Okay, let's just have a look at this now. Okay, can you feel it's getting thick?
Yeah, it's warm, man.
Okay, so it's like porridge. So we're going to pour this in now. Before I pour it in, it's looking quite good. Just see if that smells a bit like soap. Do you guys know how you smell something? You do this above the jar. You don't just go and take a big snort of the stuff. Okay. Does that smell like soap? Does it look like soap?
Yes.
Does it look like soap?
Like chicken soup.
You're good. Smell like soap? Does it look like soap?
More or less.
But it's just got to harden. You see how I can almost turn it sideways that it doesn't run?
Can I see? Can we make
Doesn't that smell like soap? No. Do you see how thick that's got me? Just look how thick. It's like porridge.
It looks more like mayonnaise.
Smell like purity.
Okay, now just watch. Just watch how thick it pours. Look. You can see it's...
I don't like when you put oil in the fridge.
So there, our knot is in the middle. And then tomorrow that will be soap. What is left over in here will also be soap. So I will find a mold and pour the rest in there. For the next part of this recording, I want to we're going to show how we can make sodium hydroxide. So, although you can buy sodium hydroxide, you can also make sodium hydroxide. So I'm going to show us how we make the raw ingredient. So we take some water. So there are various ways that we can make sodium hydroxide. We've got water. You've already seen the reaction when we take sodium metal and add it to water. But I want to show you that we can prove or show more easily that we are making sodium hydroxide, because we're going to add a chemical called phenolphthalein. And whenever you get a hydroxide, it's a powder, comes in solution as well. If you add a little bit of that powder, I've added almost nothing. That should be enough. And then with dry hands, we're going to take our piece of sodium. So I just must make sure that my hands are dry, because it reacts with water. So we take our piece of sodium. In fact, it doesn't actually matter. Let me put a bit more phenolphthalein in. Now you'll see the color it turns in the presence of hydroxide. So you can see that phenolphthalein is normally colorless. So just see what color it turns in the presence of sodium, which dropped into water forms sodium hydroxide. I'm not going to use a large amount. So that's the color that phenolphthalein turns in the presence of sodium hydroxide. So what color is that? Okay, so that color. So now we have made sodium hydroxide. That's one way of making it, and from that we can now make our soda. That is sodium hydroxide. And you will see the little ball rolling around. That's the hydrogen that it gives off. You hear a fizzing. So it's taking the water, it's pulling off hydrogens and making hydrogen gas, but at the same time, it's also leaving behind an OH. So each water molecule pulls off one hydrogen and leaves the OH behind. That turns the phenolphthalein this color. So here we can now use this to make soap. But that would be a rather expensive way to do it, especially as it's quite hard to get a hold of sodium hydroxide. So we're going to show another method of making sodium hydroxide, and that would be to use a DC power supply. So we got one lead here, and we've got another electrode here. So I'm going to put this power supply, DC power supply here, and plug it in. Now I've got to just make sure that I don't touch the two leads, because then it'll short circuit it. I would like an LED in there just to show that it's glowing, but I haven't got one, but we'll see. Okay, so that's switched on. Now we can take a clean beaker, take water, take salt. Just let me get some table salt. Okay, so here's our sodium chloride or table salt. If you haven't got table salt, you can get it free just going down to the sea. So there's table salt. We dissolve it. And let's add a bit of phenolphthalein just to see if salty seawater, any brine solution, contains hydroxide ions. So I'm putting some phenolphthalein in, and you can see no change of color, no hydroxide ions. Now this should be on this power supply, which is stolen from an old computer. Not stolen, it's my own computer, so I never steal. I just recycle. So now we're going to take, that would be the positive side, that would be the negative. Just for my own memory, I always tie a knot in the positive, because a knot looks like a positive, and this looks like a negative. It's got a straight line that's negative, that looks like it's crossing, it looks like a knot. So just for then I put a fuse in case I touch the two together, it will melt the fuse. I would like an LED in, but I haven't gone to that trouble. Now, we've got now sodium ions and chlorine ions. Dissolve, some is still solid, and a lot of it is aqueous. The solid at the bottom is not going to bother us. My expectation is that one of these electrodes is going to draw the sodium to it, the Na+. Now, which electrode will draw the Na+, the negative or the positive electrode? So there's the negative. I'm expecting it's going to draw the Na+ to this electrode. Then the Na+ is going to turn to Na metal. The Na metal is going to do what we just saw and react with the water and form sodium hydroxide. So it's going to turn pink at this electrode, and it's going to form bubbles of chlorine at this electrode if all goes well. So can you all see? So just look, I think it'll occur quite quickly. Here's the negative. Do you see it bubbling? I can't walk around, but can you come closer and just have a look? Can you see how at the negative electrode we're forming the hydroxide ion?
Actually, bubbles.
You see how it forms the hydroxide at the negative? Not at the positive. So now we're making sodium hydroxide. All happy?
So make a fire on the water and
So, if I want to make sure I only collect the sodium hydroxide from the solution and not the chlorine side, which is diluted, what I can do is put a divider in, and then I can put the electrodes on either side of the divider, and you will see that it will confine the purple to the one side, or the pink, and that side will get dark, and the other side will just form its chlorine bubble. So we're forming, it would be better if we had a clear solution to start off with, but we're forming the hydroxide on that side, and then we've got a concentrated solution of hydroxide to make soap. We could collect the bubbles of chlorine, and we can make bleach. So bleach is good for cleaning hands. Sodium hydroxide is good for making soap. You can see the bubbles. Those bubbles here, when the sodium reacts with water, it forms that hissing sound, which is what gas? Hydrogen gas. It's splitting the water and hydrogen gas. Now, for the purists who may watch this video, don't tell me that the half reaction is water goes to form hydroxide ions and hydrogen. That is the correct half reaction. But sodium does play a role. Now, in the matric exam, they will not like you saying that the sodium ions form sodium metal, the sodium metal combines with the water, forms sodium hydroxide. They want you to just say it all in one go, that when you do the electrolysis of salt water, it forms hydroxide, and the Na is just a spectator ion, because we start with Na ions, we end with NaOH, which is just another Na ion with another hydroxide ion. So we start with Na ions dissolved in water, we end with Na ions. So technically speaking, I know that the half reaction is just water being split into hydrogen and sodium hydroxide. The Na is just a spectator ion. It plays a sort of catalytic role in splitting up the water. If you look at this, you will now see that the one side is much more darkly colored. That's the side that's making the hydroxide. That's the negative terminal, negative electrode. And the other side, which it would be, if we started like this, it would be clear, and it just creates chlorine. In fact, the chlorine even makes it clearer, it bleaches it. Okay, so I could now take that solution and make soap from it. That side only. I could just suck it out and not take that side. So do you see how easy it is to make sodium hydroxide if you can't, say you're stuck somewhere and you can't get to a hardware shop. I go down to the sea, I get sodium hydroxide. If I've got a solar panel, I get 2 chunks of charcoal. They're going to use my electrodes because eventually this metal will wear out. And then I would attach with crocodile clips to the chunks of charcoal, use them as my electrodes. I would put it into the seawater. The seawater, I'd divide it in half like this. The one half would form sodium hydroxide, the other half would form chlorine. I could use the chlorine to make my water drinkable, right? If you're stuck with dirty water, you make your own chlorine. That kills any germs. You must filter it as well. So I can make my own clean water, but then I can also make my own soap. Because then I just take some fat, which I find lying around somewhere in the wilderness, a dead animal's fat, mix it with the sodium hydroxide and water, and there we make our soap. Do you see that that's now solidifying? So by tomorrow, that soap will be completely set.
It'll be usable. You just pull it out with this.
Yeah, what I would do is before it sets, I'll take a knife and just move it around the outside. And then I've got a rope that I can pull it the rest of the way. Any other questions? Is that soap safe to use? It's not going to be Lux or Palmolive, I can tell you. This is going to really kill germs because it's got so much sodium. It's got a higher concentration of sodium hydroxide than Lux or Palmolive, which is pH about 7 or 8. Your normal shop bought soaps have a low pH, like 7 or 8. This will have a high pH, like about 10, meaning it's very alkaline. But do you see how quick my reaction went? If I wanted to genuinely make soap for myself, I would use more oil. But I'm going to stick this in the staff room. I will use the soap myself.